we're going to kick off the first of two talks before afternoon tea now with Kirk Jackson from RedShield, who's going to be talking about how our browsers are helping us to be more secure.
Thank you. Okay, first up, put up your hand if you work for a bank. Okay, I've got a bone to pick with banks. So I was walking down Queen Street, which is a perfectly normal thing to do. It was 11:30 or something last night, and I got a phone call, which is a perfectly normal thing to happen. And it was my wife, who's a perfectly normal person, so I answered the call. And we were talking for a while, so I stood in a doorway so that people could walk past in their drunken state on Queen Street. And I was standing there on the phone for about 2 minutes, and then warm water dumped all over my back. So has this happened to you? So apparently BNZ don't like people loitering in the doorway of their building, and so they just have a hose that dumps warm water on you if you stand there. So yeah, that's my security-related story. Okay, it's not really. The second thing I wanted to talk about was, I think this is the first time I've presented in front of someone who taught me computer science, and I'm really proud to say that Robert was my mentor and supervisor, and kind of just chuffed he's here. So thanks, Robert. Cool. And we'll edit your name out for privacy purposes. So today we're going to talk about how your browser wants you to be secure. And I wanted to sort of just tell you what's happened since you originally formed your view of what browsers do. So back in the early 90s, Tim Berners-Lee came up with this thing called the World Wide Web, and he came up with HTML and some tags that you might recognize, and then a bunch of other ones that never seemed to make it. And now we could publish documents on the internet. And our model of a web browser at this stage was, you know, you had an application that loaded a site and parsed the HTML. You had a DNS resolver so the application could look up where that site is, and it would get pointed to a web server, and that would have some files on it, which would probably be HTML files, and it would load them in, parse them, and display them. And things were pretty simple. Then, 1993, they decided that plain text was a bit boring. Mosaic was released, and they introduced the image tag and the form tag. And then, 94-ish, Netscape came out, and they invented cookies. It's hard to believe that there's been cookies that long. Makes me hungry just thinking about it. Secure URLs, HTTPS. Brendan Eich, in a 10-day crazed caffeine-induced sprint, invented Mocha, which became JavaScript, with a document object model for the HTML in the page. And no one really called it the same origin policy, but now that web pages could do stuff, there was kind of a policy about what the JavaScript could do. So our simple web browser now has, well, I guess CSS came in as well. We now have media, like those images. We have cookies, so the browser keeps track of the cookies for a site, and then next time you go back there, it plays them back. You've got JavaScript that it loads and runs for your interactive elements. And now you could write CGI scripts, and you could actually have a web application running on your web server where it would like start up a little Perl program or a C program every time there was a request. And also the browsers could now introduce frames, so you could display bits of different web pages alongside each other, and a more formal idea of what the origin of a site is, now that there's more things happening. So if you went to www.siteA.com, you couldn't access the content of site B. Oh, that padlock, which sometimes means security, came along when they did SSL, which means we need security authorities who, for some reason, are these trusted entities that you give $1,000 to, and they run one math algorithm and return you a small file. And web servers got a bit more sophisticated, so they expanded to create session storage so that they could keep track of what was your state in the previous request. So when you came back, you could continue on your shopping purchase. You started to be able to log in now that you had forms and cookies, and so the web server would keep track of who you logged in as. A little bit later, Internet Explorer, I think, was it for an online version of Outlook, they came up with this way to do XML requests over HTTP, which was kind of the start of AJAX. And we kind of reached Web 1.0. And it was pretty amazing. Like, you could view like a website at a time from the comfort of your own home, and it only took 30 to 60 seconds for the page to load. And that was our security model, our mental model of how the browser works, and kind of we had to make that secure as web developers. We had to write secure web applications, but there was a threat that someone might be listening in on the connection. So we could use HTTPS if we had $1,000 and wanted to buy a VeriSign certificate. There was iframes, so now we have to worry about cross-site data access, so can JavaScript from one site access another, but the browser sorted that for us with the same origin policy, which is kind of loosely defined at that time. The operating system had this very non-specific threat that's probably about to show up, fuel, image parsing bugs. So like a lot of the early exploits, I guess, in browsers, or reasons your browser would crash, was because your browser was trying to load a WMF image or a TIFF or something like that, and it had a parsing bug, and so it just crashed the computer. And I guess the mitigation for that was to install a hotfix, which I believe in those days was waiting 2 years for a new version of Windows. HTML and CSS, so we had the threat of cross-site scripting, so around about early 2000s. Might have got that wrong, might have been a bit earlier. People realized that, you know, you could post some JavaScript to MySpace and everyone would say, Sammy, I love you. Cookies, now we have to worry about cookies being stolen by JavaScript. So then the HTTP only flag came along, so JavaScript couldn't access the cookies. Plugins, they've just always been a threat. And so probably everyone in this room disabled Java quite a while ago, and more recently disabled Flash. And the OWASP Top 10 came out. So this was a 2003 version, remarkably hard to find the PDF of this old version of the OWASP Top 10. I think it might predate OWASP, I'm not sure. And this was the top 10 critical, most prevalent security flaws in web applications at that time. And as you heard yesterday, please take a seat. Don't feel shy, there's lots of seats. What was I saying? As it turned out, the person yesterday was saying the same issues 17 years later, still in the OWASP top 10. So we're not really doing a great job as web developers at fixing SQL injection or cross-site scripting. But what we are doing a great job is supplying browser manufacturers with money. And I think you know who I'm talking about. So time passes. We fast forward to 2021. And how does the browser look now? Well, it's a whole lot more complicated. And so this talk really is just about running through the new things that are in the browser and how they protect us from a lot of the OWASP top 10 attacks and others. Don't know why that was an animation. Actually, you should think about how complicated it is to put this many animated boxes on a slide in Google Slides, because you have to click every single box and click the animate button. And then you should think about the percentage of time preparing this talk that went into the animation versus the content. And then you should think about whether you get your money's worth for your entry fee for this conference. Okay, so what else has changed? Well, they added the ability to have objects on the page, so ActiveX, Flash, etc. Now the browsers started storing credentials, and it would keep them separate. So the password for site A and the password for site B is kept separate and it would autofill. I know most of you turn that off. I normally turn that off. Autofill. It would store your address details and fill it in every time there was a text box that kind of looked like an address and a phone number. There's start prompting to store your credit cards. As well as plugins, we have other kinds of extensions that you could write instead of in C, you could write them in JavaScript. New standards have come. So we've known that password authentication sucks, but we haven't changed anything because why bother? It's worked for 30 years, whatever. But now there's the WebAuthn standard that lets you use U2F tokens or USB keys. Instead of running the browser as one process, which if a single website breaks, crashes your whole browser, or another way to look at it, if a single image parsing bug happens, can escape out to the operating system. Now things are sandboxed in multiple processes. Browsers started to be able to do notifications, so now up in the top corner of your screen, a browser can pop up and say you've got a calendar appointment starting now, or please enter your credit card details, or whatever they want to say. Permissions, now the user has control over all the different things that current web page can do, whether it can play audio, etc. We can store things in multiple ways, not just cookies. We can store in little databases, session storage, local storage. We can run background workers, service workers, that run either once for all our tabs or in the background when tabs aren't running in our browser. Oh, tabs. We can do tabs now. It's crazy. As well as XHR, there's the fetch standard, which lets you fetch from a web server, and WebAssembly, which compiles code in other languages than JavaScript into a safe way to run in your browser. So you can see the browser's gotten a fair bit more complicated, and chances are that many of your apps touch all these parts of the web browser. Oh, sync. Now when someone types something into their browser, it can get saved on someone else's server and then resuscitated back into your browser when you log into another computer. We now need to worry about phishing, so now there's reputation services online that your browser will check in and find out if that site is malicious. Because we had certificate authorities and certificates, we had to figure out what actually happens if a certificate gets compromised, or you publish its public key, or the certificate authority is bad. So we had to figure out how to revoke certificates. And there's been a whole series of different ways to do that with varying degrees of non-success. And then certificate authorities, we kind of had to revoke them as well. And so there's been the establishment of industry bodies that have set standards for the authorities on what they can do in order to demand their $1,000. And there's another box. Phew, I knew there had to be. And transparency logs, so now you can look and see, has anyone issued certificates for my domain across the internet anywhere? Like, is someone doing it in, I was going to name a country, but I shouldn't because this is streamed. So is anyone trying to issue certificates in New Zealand and my company's based overseas? Like, why are they doing that? But browsers also do other things as well. So we've given them all these features, but of course, people want to make money. So now, as well as content, there's advertisements, and there's trackers sitting in our browsers, and they're using the same technology, running in frames, running JavaScript, using cookies. So yeah, I think at the moment, I think that's roughly all the things I could think of, and plus I ran out of space. So that's what we deal with when we write a web application. We're putting data into this environment, and this environment is now 10 to 20 million lines of source code. And if you compare that to Unix version 6 or something, which was 5, 6, 10,000 lines of source code, you know, this is significantly bigger than an operating system was 50 years ago. So it's kind of an operating system, and there's kind of a threat model for all these bits of the browser that you need to think about. So the thing I was saying, now the browser manufacturers have money. So, you know, they release new versions. Back in the 90s, that was unusual. If you used, what was it? Was it Internet Explorer 5 that lasted forever? 6, yeah. Internet Explorer 6 lasted for like 10 years with no changes. You know, old browser companies would run out because they didn't have, would stop because they ran out of money, and so people forked Mozilla, open source. And now these manufacturers have money, they can hire people, and luckily some of these people are security minded, and they're thinking about how can we squash these OWASP style issues or other security issues sort of globally for everyone that uses our browser, which is really good because it takes a little bit of the burden off us, but most of these features are opt-in. And in the previous talk, you saw a whole bunch of the features, if you're in this room, that is. Don't know what you saw in the other room. A whole bunch of these features and how you could configure them. Most of them are configured through headers. So what are some of them? So these slides will be available, and please don't try and write down my Google URL and then send me a request to access the Google document, because one, that's really impressive, that's a really long URL, and two, it's going to be published after the conference. So yeah, you can just look at this. But okay, so the threats of malicious JavaScript or running in that HTML, CSS area. So one of the risks is cross-site scripting, and so recently, I guess since that early version of the browser, now we have content security policy, which has this way of whitelisting sources or using a strict policy with nonces, which is probably preferable. Trusted types, so instead of just passing strings around everywhere in JavaScript, you can actually pass around richer objects that you can flag as being trusted and use them in a safe manner. Which stops that client-side version of cross-site scripting, which people call DOM-XSS, MIME sniffing, that's pretty old, and sub-resource integrity, which is where you can ensure that the external files your page loads are the ones that you intend by putting hashes in the URL. Encryption, so we talked about HTTPS, but actually there's been like a whole evolution of browser encryption, and they've removed support for old versions of HTTPS and old ciphers and certificates. You can enforce it with a strict transport security header, and that initial connection when you first type in the URL leaks which site you're going to your DNS provider. So now you can have some encryption, which I guess stops it being leaked on the way to your DNS provider, but they still know what you went to. So, is the site secure? Well, there's a padlock. I know that some people in the room have a lot of opinions about the padlock because we talked about it last night, but there hasn't really been any way to indicate whether a site is secure. The padlock used to indicate that you had $1,000. Now with Let's Encrypt, you don't need to pay to get a padlock. So the browsers have been working on trying to make it more usable. There's an attack where cross-origin resources over here, if they loaded insecure content, it could leak information. So now you can block that, or the browsers block it for you. They'll enforce that passwords and credit cards will only go over HTTPS now and warn you if you try and log into a website over HTTP. Certificates, so like I said, that whole industry is kind of a mess, but the Mozilla mailing list is a very fun read if you want to go and read about the bad things that certificate authorities do. And now they have the transparency logs that the browser manufacturers force them to publish. So at least you can see if some country is generating certificates for your website. Of course, they don't actually have to do that, but and reducing the lifetime of a certificate so that you can't buy a 10-year certificate where it's very unlikely that you'll keep the private key secure for 10 years. and it's also very unlikely that the algorithms, etc., will be still relevant in 10 years. CLR Lite is a revocation database for certificates that need to be revoked, which I think is the current attempt at doing revocation. And OCSP stapling is another way of saying this certificate is kind of current that not many people seem to use. Authentication, so we talked about that. You get alerts if you send passwords over HTTP, but also alerts if you use them on suspected phishing sites. Some of the browsers now do password checkups, so they'll send a hash of your password off to a service and see if it's a known breached password. There's a standard to make it easier to change your password. I don't know. WebAuthn for using security tokens. The origin isolation, so you can opt into a lot of restrictions preventing which pages can put your page in an iframe, which pages can go inside your site in iframes and what they can do. So there's iframe sandboxing, cross-origin embedder policy and resource policy allow each side of that equation to decide who's allowed to embed them and what can they do once they're embedded. There's some new policies where you can say what permissions your page needs, and origin isolation, site isolation, which is about stopping JavaScript from one page accessing the content of another, and other related features that want to do those cross connections. And there's a nice one of these URLs down here. Forget which one. Oh yeah, the difference between same site and same origin. That's a good primer for that. And just as extra protection, now the storage is more tightly partitioned between different origins, so it's less likely for data to bleed from one site that you access to another. And the side channel attacks where you could kind of guess if someone was logged into the banking site by embedding the banking site's images in your own attacker's website and seeing if they were cached or not. Now there's network partitioning to kind of stop that. The HTTP protocol itself, so the requests themselves, well, you've probably heard that there's been some new revisions to that protocol, so it's now binary based and goes over UDP rather than TCP in some of the implementations. So HTTP 2, HTTP 3, FTP and Gopher now no longer work in your web browser, which is a real shame. Like, don't you go for Gopher all the time on your Gopher? And also like removing access to browse to dangerous ports. So which one of it was? Firefox. They've actually got this list of dangerous ports where they don't want you to be able to send any requests there. And it's kind of a dirty hack, but to mitigate attacks against like your wireless router or UPnP exploits. So I talked a little bit about safe browsing. So now every time when you go to a website, your browser is probably connecting to either Microsoft or Google to see if that website is a known bad website. And I think Google's is safe browsing, Microsoft is Smart Screen, and I think Mozilla and Safari both use Google's one. And so how they do that is they do a kind of secure hash. You're going to remind me when I'm about out of time, eh? Okay, cool. They go to a kind of secure hash and pass that to Google, and your browser checks if that site's dangerous. Although Apple have just recently gone one step further with Safari because they don't think you should send that information directly to Google and give them your IP address. Now it gets proxied via Apple, so you just give Apple your IP address, and then I don't know what the point of that was. And displaying URLs safely. So it was quite fun when I bought a domain name that had a padlock in it. But then like very soon after that, Chrome stopped displaying padlocks in the domain name part of the browser because people thought it meant the site was secure. And other kind of attacks where you use different characters. So the browsers are thinking about, how do you stop Google where the O's, google.com where the O's are actually like from a language that's not English. Eek. And data URLs. There was a Facebook hack thing where there's a Facebook message that says paste this into your browser address bar and press enter and see something cool. And it was data base64 code. And when you put it in there, that was JavaScript that ran in Facebook and did stuff in your browser. Cookies and CSRF. So yeah, lots of stuff's changed around cookies. Your app's probably broke sometime in the last 12 months when same-site cookies became compulsory, which is really good. So now we have kind of a browser built-in feature to stop cross-site request forgery, but that shouldn't stop you using CSRF tokens. Changes to how cookies are implemented in browsers. A lot of changes are happening at the moment around advertising and tracking. So cookies are used to track whether you've seen an ad, so that they can track whether you converted a week later and then give money to the person that showed you the ad or something. And so that when you search for a word, you see the ads for that for the rest of your life as you travel along the internet. And so there's been work on third-party cookies and a lot of changes around that. Actually, that's on the next slide. There's also been changes to how incognito mode works, because incognito mode people thought meant secure mode, and really what it meant was just a separate bucket of cookies mode. So two sites that you used on incognito mode could both see that Anyway, private click measurement, which is, I think, Google's suggested approach to how you could do tracking people all across the internet and attributing payments back to the original advertisers while still keeping their business model going, while still looking like you're being private. Other ever cookies. So ever cookies is the term of figuring out ways to track people without cookies. And so there's been a lot of lockdowns on that. Cross-site leaks, which is a new category of, I guess, terminology for a bunch of different ways to leak information from one site to another. How many minutes do I have left? 2? Okay, cool. Oh, okay. Sure. Jeez, I thought I finished at 2. Okay. So yeah, cross-site leaks. Have a look at them. It's kind of interesting. So it's, what information gets leaked when you embed an image on one site, you embed it into another site. How about if two DNS requests happen at the same time? How about if you put something in a frame? So there's a fair amount of work and some nice write-ups on the excessleaks.dev site. Abusive notifications, so what happens if an app just keeps sending notifications into your corner of your operating system saying, install our iPhone app, or keeps popping things over saying, click here to accept our cookies. So the browser's trying to implement restrictions on that. Advertisements that are actually Bitcoin miners is a pretty cool way to make money, though I don't know how you'd make much money out of it. I guess distributed computing or something. The future is here. And referrer policy, so you can keep track of how people got to your website. So try and, plugins. So isn't it awesome that Java is finally dead? Pretty much everywhere, except in the enterprise, and on the enterprise server side, but Java plugins, they don't work. If anyone ever says to you, can you make Java plugins work? You should scream and get a new job. And Flash is dead as well, but luckily someone wrote a Flash emulator in JavaScript, so you can still run Flash. But Flash is basically dead. And the old Netscape API, which was kind of a native code API, has been replaced by extensions that have a much more limited access to the operating system. But unfortunately, extensions, damn. It kind of got worse, not better. It used to be that we just had to hate Adobe. But now we have to hate anyone that can write 3 lines of JavaScript and publish it in the Google store, which turns out is everyone. And so there's extensions for everything, and they're all malicious. And there's no way for you to control it at all. How do you even know? So we rely on the app stores or the extension stores, Chrome and Firefox, Safari, to try and police it. But there's tons of them, and they're all pretty much evil. Even the good ones turn evil. So, you know, like the ad blockers that get bought by companies and then they start shoehorning stuff that only shows you their ads. Ugh. Anyway, I'm still running extensions. Reducing permissions so that extensions can't do as much and the user gets told what they can do. But when you get an extension that says this needs to be able to read and write all data on your page, you probably still click yes anyway. And WebAssembly is quite cool. I haven't done much with WebAssembly, but it's a sandboxed execution environment. So you can write Rust code or Ruby code or other languages, and it compiles. I guess it's kind of like the idea of Java applets run anywhere, but maybe done this century. So fetching data. So I mentioned that there's 3 ways to do it. You know, the regular request, you've got that XHR from the late 90s, and you've got fetch. And fetch sends extra headers so that the server can restrict who's accessing them a bit better, which website is accessing them. And the same origin policy limits the results of those requests. And you can opt in to allowing a bit more promiscuous access of your data. Phew, so since I went really fast, I'm actually going to finish early. Just a little bit of foreshadowing there, though you might have noticed the summary word at the top of the slide. So yeah, every one of these features is something that we have to think about when we're building web applications. And this is kind of an introductory talk, but I want it to be kind of an overwhelming introductory talk. Because it is kind of complicated, and unfortunately the default doesn't opt you into all of these things. So when you're writing the web application here, now you have to think about using the right mouse. You know, when you're writing a web application, you have to think about, okay, are my cookies scoped to just this site? What else is on my site? If we're using cores, what's the right way to do cross-origin requests? Should I return a star or should I return a site name? What happens if users enter their credentials in here? Do they get synced to Google Cloud? Do we really like that idea? I guess it's okay because they say it's safe. And you have to go through this kind of threat modeling process where you try and think about, you know, what's happening on the end user's computer as well as what's happening on your web server. As I said, browsers are the operating system of the web. Like in my life, I've written much, much less than the number of lines of code that are in Mozilla. You know, they're huge projects, and there's all these sort of corner cases that they have to work around. But the good news is that the browser vendors are working hard to improve the security posture of the web, and I would like to think that some of them are actually working quite hard on privacy as well. So in particular, Safari, I think, has a pretty strong privacy approach to try and stop tracking and things like that. I don't personally use it, but they seem to be doing a lot of work, and I think it's because they sell AirPods rather than advertisements. So, you know, they have a different business model. Although apparently the AirPods sales business is like enormous, like bigger than New Zealand's GDP, and just in headphones, I don't know. So, you know, browser vendors are now on our side and trying to make the default posture of our applications a bit more secure, but we do need to opt into some of it. So, yeah, threat modeling, all of it is hard. And it's also changed a lot since we first, especially if you're like 40 plus, since you first used the internet like me, what the browser does is a lot more complicated now than you might be thinking in your head, where you think, well, it loads the HTML and it runs it, it renders it. Cool. Oh yeah. So before I take questions, I will just talk a little bit about some people that I find amusing to follow on the internet. I really enjoyed reading Eric's posts. So he's worked on Edge and Chrome. Adrienne Porterfeldt, she's quite funny and also has done a lot of work around security, as have the other Chrome team members. Anna from Firefox, and John Willand is really privacy focused from security, from Safari. So yeah, if you want to find more, you can make a Twitter subscription list of about 10 people and keep on top of security changes in browsers. And also, as you've seen at the bottom of the slides, there's lots of links. And now there's industry collaboration on web development documentation, which is really good. Cool, okay, that's my talk. Are there any questions? And I'll repeat them for anyone that's online.
First of all, I want to congratulate you on getting all those boxes aligned.
Thank you.
Second of all,
I was questioning my life choices. Oh, so the comment was the boxes were aligned. Yeah, cool, sorry, I had to repeat it.
do you have any recommendations like yourself with which plugins would be useful for assisting with like security and or privacy? Like, do you have a favorite script for disabling adverts?
Oh man, I don't know if I've done enough research to give you like an authoritative answer, but I can tell you the ones that I kind of like, which, you know, ad blockers, yeah, I'm a fan. There's the Panopticlick, is that what it's called? That one which tracks all the trackers as you browse, the EFF one. I personally segment all my browsing. So in Firefox, there's a container, oops, wow, congratulations me. There's this containers approach where you can segment your browsing by host. And so I use that so that, you know, I also use profiles in Firefox because I'm extra paranoid. So this one I only have one container, which is my personal email, Gmail, and anything else I'm using a temporary container. So each time I open a new site, it starts with a blank set of cookies. So this is container 130 that it's just created. And so I quite like that. And Chrome doesn't have the temporary container feature, I don't think, but it has the drop-down people menu. So you can have like a profile that you just use for internet banking. And so you know when you're using Facebook, you've never ever logged in to internet banking from your Facebook profile.
So did you have a specific plugin that used that functionality that gave you that GUI?
Yeah, so I think if you search multi-account containers on Firefox, and I think it's called temporary containers. I don't know. So this is just me. So I have paranoia, but I don't have expertise. And I haven't reviewed the source code of these. I did read the source code of the containers one because it's really simple, because that's built-in feature and they're just exposing the GUI. Cool. Any other questions? Let's see if there's any online. Yeah, so at the back, is that Tom? So the question was, do I think there's any hope of fixing stuff like Electron? I think they're doing a great job of building rockets. I mean, I think, yeah, I mean, all you have to do is tweet the name of a cryptocurrency and the economy changes. So, yeah, I know I don't really have any opinion about Electron apps, except that I found cross-site scripting bugs in them. And it's kind of like, yeah. Cool. Any other questions? I didn't answer that question, but that is my strategy when there's questions. Just repeat your question and then dodge it. Yeah?
You didn't include Gopher in your browser history.
I didn't include Gopher in my browser history. Yeah, actually, I didn't really use Gopher that much. A little bit at university because I could get to some sites that I couldn't get to through the university proxy, but yeah, sorry. Maybe we were born in different years. Oh, sorry, yes, at the back, middle. Yeah, so the question was, any thoughts on TLS 1.3 and how it's going to work on the enterprise? So I assume that you're talking about enterprises that want to intercept TLS connections from their employees, look at what they're doing, and then re-encrypt it when it goes out to their banking site. Yeah, I mean, I kind of equate enterprise with China there, so I'm kind of on the side of TLS 1.3, but this is not a political discussion. I don't know practically how enterprises could function. Luckily, I don't work in places that do that, so yeah, we just got political, sorry. We can edit that out. Cool. Oh, another question, yeah?
But on that, I mean, that is a requirement that someone have some intrusion from. So they're going to be looking for solutions at some stage.
That is a requirement that some enterprises have, and so they'll be looking for a solution at some stage. Yeah, I mean, or they could just trust their employees. I don't know. I don't know. Sorry, I'm being flippant. I don't know the answer to that. I guess there'll probably always be some way that enterprises can enforce stuff because they control the desktops. So, but I just don't know what that will be. Yeah. Cool, and on that flippant note, thank you very much.